Before we get into today's story, subscribe to In the Beginning so you never miss these forgotten survival techniques that shaped history. Because what you're about to learn isn't theory. It's a method soldiers in World War II used to survive freezing nights and maintain operational readiness. A trick that relied entirely on observation, ingenuity and a deep understanding of heat management long before modern insulation science existed. For the first minute, picture a field hospital in northern Europe, winter winds howling across tents, snow piling against the walls, and temperatures dropping well below freezing. Standard shelters and stoves provided some warmth, but not enough. Hypothermia threatened the wounded, the sick, and even the most seasoned soldiers. Yet, by constructing what came to be known as the heat dome, medics and engineers created a self-contained thermal environment that changed everything. This is the story of that trick, and how you can apply its principles today. So, the heat dome works by concentrating and recycling both body and environmental heat within a confined space. According to World War II field manuals, soldiers would construct a temporary shelter using only the bare essentials: a small tent or a wooden frame, insulated with walls made of burlap or canvas. On top of that, they'd carefully arrange a top layer designed to trap the rising heat. The dome shape, well, that was absolutely critical. By arching the roof and the walls just slightly inward, they were able to minimize air movement right at the top, where hot air naturally wants to rise. This clever design allowed the warmth from bodies, stoves, and even small fires to build up rather than escaping straight away. Unlike your typical tent, which tends to vent heat through loose fabric at the peak, the heat dome actually turned the ceiling into a sort of reflective, insulating barrier. For anyone who needs to keep warm in a temporary shelter today, the idea is really straightforward. Build a semi-enclosed dome so that heat rises and collects in a concentrated space, rather than just drifting off and dispersing. The materials and construction were, well, ingeniously low-tech. Soldiers often layered canvas or heavy tarpaulin over lightweight timber or collapsible frames, then added insulation with straw, blankets, or even sandbags around the walls. The top of the dome would be covered with an additional layer of cloth or tarp, creating a pocket that trapped rising heat. Historical accounts suggest that even in sub-zero temperatures, soldiers inside a properly built heat dome could remain warm with minimal external fuel. The key wasn't quantity of heat, it was retention. Modern survivalists can replicate this with tarps, reflective blankets, or even snow blocks for insulated walls, as long as the rising heat has a contained area to accumulate. One of the most critical lessons of the heat dome is, understanding airflow. Too much ventilation and heat escapes, too little, and carbon monoxide or smoke from a stove becomes dangerous. World War II guides emphasise small controlled openings near the base for fresh air intake while leaving the dome top sealed. This created a convection cycle where cold air entered low, warmed quickly, and then rose into the dome's upper pocket. Smoke from stoves or lamps naturally rose and escaped slowly through a vent, ensuring oxygen remained available without sacrificing warmth. Anyone building a temporary shelter today can use small gaps at floor level to feed air while keeping the ceiling tightly insulated. This is the same principle the soldiers used to survive harsh winters. The heat dome trick also relied on heat reflection and absorption. Soldiers learned to line the interior with reflective or dark materials. Burlap, canvas and even tinfoil from rations were used to redirect heat downward and keep warmth concentrated where it mattered. Floors were insulated with straw or extra blankets, preventing conductive heat loss to frozen ground. Some units discovered that the body heat of a small group could maintain a surprisingly warm microclimate, sufficient for both rest and treatment of frostbitten limbs. The physics is simple. Combine insulation, reflection and containment, and even minimal heat sources become exponentially more effective. Practical applications for modern survivalists and campers are straightforward. If you're in a situation where warmth is critical, consider constructing a small dome-shaped shelter using tarps, blankets or other insulating layers. Raise the roof slightly to create a pocket at the top, line the walls with reflective material if possible, and insulate the floor thoroughly. Small heat sources, whether body heat, chemical hand warmers or safe fires, will accumulate in the dome, keeping the interior significantly warmer than ambient conditions. This method is effective in snow, wind or rain, and it works even with limited fuel. In fact, World War II reports indicate soldiers could survive nights with less than half the fuel a conventional tent would require, simply by employing the dome principle. The heat dome method is more than a historical curiosity. It teaches a broader principle about survival. Retaining heat is not always about generating more. Often it's about containing and concentrating what already exists. The soldiers who devised this trick weren't inventing new materials. They were observing nature, experimenting in the field, and applying geometry and physics to real-world challenges. It's a lesson that extends to modern survival, bushcraft, and even energy-efficient housing. Managing air movement, reflection, and insulation can make a dramatic difference. By studying the World War II heat dome trick and adapting it to today's needs, you can increase comfort, conserve fuel, and survive extreme conditions without relying on modern infrastructure. If you found this guide valuable, subscribe to In the Beginning and share this video with fellow history enthusiasts and survivalists. Preserving these forgotten techniques ensures that the ingenuity of the past continues to inform practical solutions today.